Welcome to Tech to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen Zone Jason Schwartz.
Thank you, William, and thank you everyone for joining me today. We've got a case study on spotting on brass parts, and actually, we've got two different problems that we encounter at customers when we're cleaning brass. The first problem that happens quite common is white spotting, and we'll address that first in a particular customer scenario. And the other thing that we see often is dark spotting, and that's kind of a completely different animal. And after we talk about white spotting, we'll go in and talk about how you get rid of dark spotting as well. So, customer number one, this particular customer was dealing with some white spotting, and they called us in. The important information is that they were running only brass. They were concerned about corrosion, and like most people who deal with screw machine brass or really any type of customer facing brass, they wanted it to be bright and shiny. Appearance was key to them. So the white spotting really wasn't acceptable. Uh, the process they had when we came in was they were using a competitor product in the wash, and they had a wash, rinse, dry immersion setup. The competitor's product was running at 5%, 130 degrees for about 5 minutes. They did a tap water rinse, and then they had a competitor RP running about 2%, again, keeping that 130 degrees and then a heated blow off at the end. And that's a pretty good standard process. But we had to just kind of figure out why they were getting these white spotting. So the first thing we look at is what is the usual cause of white spotting? And it's almost always residues left on the parts. A couple of things can contribute to that. It's either insufficient cleaning, hard water, soap residue, which oftentimes is from insufficient rinsing. And that's kind of how you see that graphic on the right. We're all familiar with hard water, soap scum in our showers and faucets at home. Uh, in the manufacturing process, it's no different. A lot of times that's where some of this comes from. But another thing that you've got to look at is your drying process and your RPs, because your RPs are compounds that are left on the parts by design, right? They're designed to be left there to prevent rust and other types of corrosion. So we have to figure out which one of these is causing the problem, and then we can go and solve it. So the first test we did was we basically just took the parts out halfway through. We didn't do any RP cycle, we didn't do a drying cycle, and just saw how they were. And that eliminated several of the variables. And in actuality, it gave us spot-free parts. So we knew that we were getting sufficient cleaning, sufficient rinsing, and so the spotting had to be coming either from the drying process or the RP. So, what are your possible fixes, right? You can put in an air knife, you can introduce some rotation so you don't get pooling on the parts, you can introduce a better blow off, or you can adjust the RP concentration or look at the RP itself. And so what we did in this time, especially because RP jumped out at me, right? RP is rust prevention, and you don't really see rust on brass. You see corrosion, but you don't see rust. So we took a deeper dive into what the product they were using, and it turned out they were using an amine-based rust preventative that was meant to prevent rust on steel, right? It not really didn't do anything for their brass, but they were so concerned about corrosion that they threw it in there and they thought it was helping. That was what was causing the white spots. So when we ran a lab test at Kaizen, we chose METALNOX 6310, and we chose it specifically because it's a combination cleaner and corrosion protector. And again, we're talking about corrosion protection, not just rust. 6310 has corrosion protection agents in it that are specific for yellow metals. It's also got a little bit of brightening in it. When we ran the lab test, uh, not only did we get spot-free parts, but as you can see in the picture on the right, we actually brightened them up. And so for somebody who was really concerned about appearance, that was a big win for them on two fronts. We eliminated the spots and we got brighter parts. So when we put this process into their machine, we actually changed things up a little bit. We went wash 6310. We kept their concentration and temperature because that was solid. we actually moved the RP, the CP stage up one. So we put an extra little bit of 6310 in there, concentration 2%, because that's what they were running. And then we did the rinse and the dry. And it's important for this is that final rinse, we like to say you're only as clean as your last rinse. And that helps make sure you get some spot-free parts that you don't have any soap residue on there. The nice part about the 6310 and the corrosion agents in there, or the corrosion protection agents, is that they're very hard to rinse off. They're designed that way. And so even though you're rinsing the parts, we're leaving that corrosion protection behind, which is what we want to do. And so at the end of the day, we really helped them out. We got to solve their problem, but we also made the process a little bit more efficient. They no longer had a need to maintain two products. They were using conductivity to monitor their wash chemical, titration to monitor their RP. We changed that and made them, they just have to do one process now, the conductivity for the 6310. And they don't have to worry about drag out anymore because on the wash stage, we're dragging out the same product, the M6310, into the rinse stage, right? So again, one concentration method, no drag out concerns, easier process to maintain. It was an all around win for the customer. Now, going back to customer number two, they were dealing with a completely different animal, dark spotting, right? And for this particular customer, another important thing to note is that they were running brass, aluminum, and ferrous parts, right? So they had all the different types of metals that you could think of. They were running them all through their shop. They had one washer, one central washer, everything went through. They did need rust protection. They had their steel parts rusting in the past, so they wanted to make sure they put on a steel-based RP for those parts, and they wanted no spotting on any of the brass parts. So if you look at the picture to the right, you can see that these spots are very different. They're dark, and we'll get into why that is in a second. But briefly on their original process, a couple of things jumped out at me, right? Just like the previous customer, they went wash, rinse, RP, but they were only running the RP for the steel parts, which was fine. That kind of jumped out that we weren't dealing with some type of residue on the part, right? They were only doing the RP on the steel. Secondly, temperature 170. Wow, that's hot. Uh, so for brass, as we saw earlier, you really want to run in that 130 range. That's a sweet spot. So when we're looking at how to solve this problem, right? What causes dark spotting? And for dark spotting, it's almost always corrosion, right? And when you see brass, and this picture below is really nice, gives you a good example. A lot of times you want that corrosion. You can have this nice patina that gives you these antique looks or a darker brass. And that's great if that's what you're going for. But most of the time, if you've got a screw machine shop or you want a bright, shiny brass part out at Home Depot, you don't want anything. You don't want anything on it. You don't want any spots. You want a nice, uniform, shiny finish. So what's causing that oxidation or corrosion? Well, it's almost always heat and humidity. So excess heat, that 170 that we saw earlier in their process, was playing a big factor in that. The other thing is if you got very clean parts, uh, dirt and oil can actually act as a preventative for corrosion. So you clean all that off, you put excess heat in there, and you can get dark spotting very quickly. Aqueous-based rust preventatives. In this case, if you're doing it, if you're applying an aqueous rust preventative that's not designed for brass, you're going to get dark spotting or the white spotting that we saw earlier. This actually wasn't a problem for this customer, but it's something that we see quite often. Poor drying, always a problem. If you leave moisture on those parts, you got hot parts coming out of a dryer that are still wet, you're going to get some corrosion. All right, so now that we know what's causing it, how do we solve it? Well, this one was pretty straightforward. We went with a different product this time. We went with METALNOX M6310 CP, and that's because it has a combination cleaner and protector for all the different metals. It's got aluminum protection, yellow metal protection, steel protection, all built into one. And that was important because these guys are cleaning everything, washing everything, and protecting everything in the same washer. So in this case, we actually kept their same process setup, right? We moved the 6314 CP into the wash, kept that one or dropped the temperature down to 130, because again, we don't want too much heat in there. Rinsed it off, and so that's where the process for the brass parts stopped. Because remember, our brass protectors are not easily rinsable, so we're able to rinse off all of the soap residue, send them into the dryer, and get clean, spot-free parts. Then if they were running steel, we put in the 6314 CP into that third tank, let them do that wash, rinse, RP, and then drying out the door so that they won't get any rust down the line. So again, uh, benefits, just like before, that brass CP is not easily rinsable, so we're able to rinse the parts, get them clean and spot free. The extra CP in this case was only for the ferrous parts, which is what they needed. They needed that rust protection for the steel they were running through their washer. And again, we cut out the need to maintain two products. One concentration control method makes your process not only from control but maintenance much, much simpler. And really important, lower that heat to decrease the tendency of the brass to darken. Because even if you don't get spots, a lot of time excess heat will cause brass to go to a darker shade of that yellow brown. So wrapping things up, again, white spotting, like we saw in the first case, best dealt with by looking at the rinse stages, because that's usually some type of residue, whether it's soap scum, hard water residue, cleaning residue. Uh, that's where you attack the rinse. That's your best place to look at white spotting. Dark spotting, 99.9% of the time, some type of corrosion. You got to add CP into even the wash and rinse stages together. Uh, if you don't get that CP on there right away, you can actually get corrosion in process, very similar to flash rusting with steel. So getting the right CP and a combination CP cleaner is your best bet. Uh, no matter what you're running brass wise, heat is not your friend. It tends to increase corrosion, and even if it's not outright dark spotting, you'll get darker parts that aren't as shiny, aren't as have kind of a dull luster to them, which nobody wants. Uh, all in all, though, combination products with cleaner and corrosion protection built in really make your life simpler, especially when you're dealing with spotting on brass. So, over the years, I've had a couple of questions asked to me when I've come out to customers, and I figured I'd talk about a few of them now. Uh, the most obvious one is, can you recover the parts that have spots on them? Get asked that one all the time. And simple answer, yes. White spotting, very easy. Rinse the parts. You can either run them right through your wash process again, running through an extra rinse and dry. Most of the time, that's a simple residue that can come off. That's pretty easy to recover, but you don't want that rework. So tightening up your process is your best long-term solution. Dark spotting, again, yes, this one gets a little bit trickier, right? Depending on how deep set that corrosion is, you may or may not be able to recover them easily. If it's not too deep set, using a mild acid product like a citric acid product will help recover the parts. Uh, if it's really deep set, you can go old school and polish your brass. Uh, People are doing that for a long time. I've seen with the corrosion, especially the dark spots, you usually can recover it about 70% of the time. If it's really deep set, it can be difficult, but there's still a chance. Uh, Spotting seems to come from either the quality of the water or corrosion caused by water. I had an astute customer point this out, and they asked me, does solvent cleaning work? The answer is absolutely. Solvent cleaning eliminates all of the water. That's one of the advantages to solvent cleaning. Solvents can be a little bit more expensive. The equipment side can be expensive. It all depends on what works best for you. There's advantages, disadvantages to both, and your chemical vendor, hopefully that's KYZEN, will help you work through which one is best. But solvent cleaning is absolutely an answer for brass cleaning, and it can eliminate a lot of that spotting as well. Corrosion protection options for solvents. People like the second customer are worried about corrosion, both rust on steel, corrosion on brass. Is there a way to work into corrosion protection to solvents? Yes, it's not as easy, but it can be done. They tend to work better on steel. The wax-based corrosion preventions perform kind of a protective barrier. They're not bonding to the surface like some of the aqueous ones are. They're really a barrier method, and they work pretty well. But again, that's something that you can sort through with your chemical vendor. The last question that has come up a couple of times over the years, people get spots on their parts from dried on coolant, and they say it's really difficult to wash off. Yeah, we've seen that. It can be, especially if you're using solvent or a quick wash process. If you've got dried on coolant as opposed to wet coolant, it can be a lot more difficult to clean, and you might not get those spots off. That's a cleaning issue. That's not one of the issues that we talked about earlier. Best way to deal with that, actually get some fresh coolant, soak the parts in that. In chemistry, we like to say like dissolves like. So the closest thing to those spots is actually the coolant you were using. So you get that fresh coolant, you soak them in that, tends to loosen up the spots, run them through your normal wash process, get a much higher success rate of cleaning it off with some fresh coolant. So that's what we've learned over the years. I hope it's helped, and I'm going to turn it back to William.
Thank you, Jason. And thank you guys for tuning into this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered during the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.